Welcome back, everybody. Welcome to the final session of day 3 for ETS. We're talking about resiliency here, planning for the future and not the past. Just trying to, get a jump start on how to be more resilient now and against the threats we know are coming / developing. So to talk about that, we've got some great panelists here. Gary, why don't start introductions with you?
Sure, thanks, Dylan. Happy to join the panel today. So I'm Gary Rackliffe. I'm the VP for Market Development and Innovation at Hitachi ABB Power Grids, focusing on market development for the utility sector and then innovation, tracking the drivers in the industry and also internal to our company around grid modernization, digital transformation, and how utilities are addressing the energy transition.
Thank you. And we've got Alexina here as well.
Hi, yes. Thank you so much for having me here today. I am working at AES. I work in their innovation space. I guess the easiest way to sum up all the variety of things that I do is to say that I run the governance for a variety of our innovation areas. We really have 3 areas, everything from your basic core innovation, right, the incremental things, all the way through sort of exponential next generation technology. And I have the privilege of being involved in the governance of those activities. So happy to be here.
Happy to have you. And finally, we've got Andrea.
Hello, everyone. Thank you for having me. I'm Andrea Rotolo. I'm the Senior Director of Grid Modernization and Innovation at Liberty, which is the parent company of more than 40 subsidiary utilities in electricity, water, wastewater, and gas throughout North America and in Chile and Bermuda. I'm passionate about customer-centric grid modernization, adapting to climate disruption and reducing carbon emissions and building the more reliable, resilient, smarter grid of the future. The main focus of my work is setting up and leading innovation teams to accelerate our progress on all of those important aspects of grid modernization.
Thank you. So let's get in and talk about we'll front load the scary part when we're talking about the threats to the grid that are ongoing. There are always many of them. They're plentiful, but there are a few that we're going to be focusing on primarily for this panel, namely cybersecurity, the effects of climate change causing increased disasters, and probably aging infrastructure as well. So let's start with Gary and just say and ask: are threats to the grid developing or evolving faster than utilities can keep up with?
So I'm not sure if threats are developing faster than utilities can keep up, but there certainly are challenges. I think you mentioned a couple of them, but the threats that we see to utilities is one, aging infrastructure, 2, security, both the physical security of the grid as well as cybersecurity issues, new bad actors continually developing threats from a cyber point of view. And now we're looking at supply chain issues as well from a cyber perspective. Climate change, we're seeing more frequent, more severe storms that are impacting the grid. Also, some examples, what happened in Texas earlier this year, what happened in California with the heat wave last year, wildfires. And in the 4th area, not sure if this is a threat per se, but certainly a change. Climate change and decarbonization are really changing the utility landscape. This last item, the energy transition means more renewable generation. We're seeing utility scale solar and onshore and offshore wind being integrated into transmission. We're seeing distributed or grid edge resources, distributed energy resources or DERs, plus increasing load through electrification at the distribution level. And then with the US generation currently 40% carbon free, we expect investment in wind and solar generation to continue as we try to drive towards 100% carbon-free generation. And then electricity, as an in-use source of energy is expected to grow from 20% today to 50%. And so substantial increase in load, a lot of that being electrification of transportation, but also industry buildings and other applications. So change coming from all directions.
Andrea, do you agree with that assessment? Do you, in regards to the relationship between threat development and response development from utilities?
Right. So from my perspective, and this is probably because of how I look at the world and how I think we need to accelerate on innovation, I would say that the short answer to your question, are threats to the grid developing faster than utilities can keep up with? I would say the short answer is yes, they are. Anyone can see the evidence of that in the news. There are millions of people left without power during extreme weather events every year. There have been cyber attacks on gas infrastructure in the US and electric grids in other parts of the world. The fires in California, as Gary mentioned, that are caused in some cases by grid failures and often cause the utilities to shut off power to avoid causing more fires. And the big outage last winter in Texas from unprecedented cold weather are some of the top examples. So I agree that we have an issue with climate change there with Gary. For those of us who work in the sector, we can see more than most people see in the news. And the reality is that the US grid is the oldest in the world, and a lot of it is past due for an upgrade. So utility companies are working hard to upgrade the grid as fast as possible, but it's fair to say the threats have evolved faster than the solutions have been put in place. In the same way that coastal flooding and ransomware attacks have evolved faster than cities have been able to hold them back.
And Alexina, what is your perspective?
For sure. Well, I think, first of all, certainly Gary's hit on a number of the topics that I think about. At AES, we do both utility work and we do generation work. We do a ton of innovation, hence my role. And so when I think about the changing environment right now, I sort of classify it into three areas: growth, complexity, and risk. And, both things that Andrea mentioned and Gary mentioned, I think fit neatly into those categories. So growth in certainly the load points. One thing that I was talking about today with others that stands out to me is that the growth is not just about shifting from fossil sources to renewable sources, right? That's not, you could say that's a one-to-one shift potentially, although certainly would love to get into a conversation about the fact that renewables can be more efficient than fossil fuel sources. But then, as Gary also mentioned, we're looking at electrification of other processes that are not currently electrified. So a lot of growth, a lot of complexity from the distributed energy resources being put into the grid, but also the fact that it's, no longer going to be purely centrally located, dispatched, right? It's going to be a lot of different assets that are going to come online when they come online. They're going to be used when the people who have access to them choose to use them. And yet we still have to solve for the physics equation that is our grid. And of course, the risk, cyber, weather, huge things that we're looking at. So are the utilities really in a position to be, solving these things? And I think Andrea mentioned this in reference, but just to drill down a little bit more, our current grid was built before we had computers in place to really, catalog, look at the architecture and say, these are the things that we're putting on the grid. This is why we're putting them there. This is the plan that we have behind it. And so, can we transition from that sort of lack of awareness, right? And certainly people are putting sensors out, people are trying to catalog. But are we cataloging an outdated system? Are we cataloging a system that is not going to keep up with or change fast enough in light of that growth, complexity, and risk? So when I think about the preparedness or the speed at which we're moving, I almost think, we can't worry about cataloging the past. We have to leapfrog to the future. And can we get our minds around that leapfrog process? So to call the hearts and minds through this conversation through conversations that I'm having all the time to say, utilities, you've got this reputation sometimes for not moving quickly or doing things incrementally. Here's a great opportunity to prove everyone wrong and leapfrog to the future, because we need to address that growth, complexity, and risk, or else, our systems are just going to be in trouble.
Okay, so you've all done a good job of laying out the stakes and the situation on the ground, as it were. And that was a great great tie into the theme there, Alexina, about how we're gonna stop looking backwards and start looking forwards. So let's talk about, in what ways do these threats also present opportunities for a better grid long term? Andrea, let's start with you.
Excellent. This is what I love to look into, the opportunities, right? So pressure to adapt can be definitely a great motivation to improve technologies and services. And I view this just like the pandemic forced very fast improvements in digitalization, virtual workspaces, video calls, and ways of doing business. And these changes brought a lot of business benefits that will stay in place going forward. The pressure on the utilities sector to adapt to climate disruption and other threats will make the grid much smarter. So move us much more quickly to the smart grid of the future, a grid that is going to be more efficient, lower carbon, and ultimately safer, more resilient, more reliable, and able to provide more benefit to society. So any challenge always brings an opportunity, and in response to threats, the utility sector is evolving to a better state than it has ever been in before.
Gary, would you like to add on to that?
Certainly, I would definitely echo what Andrea said regarding we have the opportunity to make the grid more resilient. We also need to make sure the grid remains reliable. We can improve efficiency, particularly we have some efficiencies, for example, at the transmission level, but also in use efficiency. We need to be not only resilient, but also flexible, to able to accommodate renewable generation and some of the changes that we're seeing, and also with distributed energy resources. Higher levels of automation, whether it's distribution automation or substation automation, technologies which can improve situational awareness. We need to maintain security, as I mentioned previously, and also be sustainable. I think some of the key technologies that we have today that are really pushing the grid forward are the applications of power electronics. When we look at wind, solar, battery storage, they're all connected to the grid through power electronics. HVDC and many FACS technologies are also based on power electronics, and we're seeing broader use of these technologies being applied to the grid. Also the digital tools. Through these, we can position the grid for the longer term, both at the transmission level as well as at the distribution level. And what we see is the opportunity. We see electricity being the backbone of the energy future. Sustainable, carbon-free generation, increased flexibility with automation and batteries, energy storage, and electrification. So green hydrogen can also provide seasonal storage and provide low carbon energy for in-use applications, which are not easy to electrify. One example being long haul trucking for freight. Probably not the best application for batteries because of the weight of the batteries that would be needed to support the longer range. But we see electricity being our energy backbone, and that creates great opportunities.
Again, and Alexina, do you have any opportunities that you see?
For sure. I mean, opportunities are limitless. And like Andrea, I'm very excited about opportunities. Sticking with that theme of the growth, complexity, and risk, when we talk about growth, echoing Gary again, there's just a lot of opportunity for thinking about how those of us who, generate and deliver energy can even change the way that people currently think of consuming energy and interact with it. What can we do, for example, to become a strategic partner Data centers are an obvious choice, right? How can we be a strategic partner to a data center to say, hey, where are you siting? Where are the benefits of siting in that location? Can we actually customize a load profile for you? You may have, some of you may have heard or seen in the news about AES and Google, for example, partnering on a 24/7 carbon-free guarantee of load match, right? So thinking that way in service of some data centers that they have. And so how can you really sort of help those, increasing or new consumers of electricity load, make energy as a strategic thought, as a strategic asset within their value chain. Also in that growth category with CapEx overbuilding, we often look at the current grid and we say, okay, well, we're just putting in a bunch of extra CapEx, right? For a lot of very important resilient reasons, among other things. How could we, as we look at the ability to put in software technology, the digital technology that Gary was mentioning, to say, okay, can we actually look at the system from an end-to-end perspective and say, maybe we don't need all of these assets. What we need to do is we need to orchestrate them more efficiently, and then we can do better planning, more efficient planning, or even just-in-time planning. I don't pretend that this is something we do tomorrow, but if we're building today in an accelerated way to try and help this transition that I think we need to do in an urgent way occur, if we even think about how can we more efficiently allocate our capital and time, we're actually benefiting the decarbonization transition. Trying to keep it brief, but also hit on complexity and risk. As we look at those fast, intermittent, and distributed renewable assets in our distributed energy resources, I think, one of the exciting things that comes up with access to those DERs throughout the system is how do we use them to do voltage control? How do we use them to deliver load and demand, at the right time and at the right place? Really, instead of seeing them as hurdles to an efficient operating grid, we can actually call on them to be critical players in resiliency. And then on the risk level, again, going back to using digital applications and software as a way to elevate transparency in the grid system. And with that transparency, how do we actually mitigate risks, right? So if we know or can plan better for outage events, or if we can see unusual activity occurring in the grid, because of the transparency that those digital systems could bring to our future operations, we may actually be better risk assessors and risk mitigators.
Thank you. So what are some use cases that are giving you optimism for grid resiliency going forward? And I'll let anyone who has something they really want to talk about go first.
Yeah, happy to jump in. In my view, some of the most important grid technologies are microgrids and nanogrids to address grid resiliency. And for those who are not very familiar with this, I know that in this audience a lot know, but those are systems that are usually connected to the larger grid, but can also disconnect and keep the lights on locally in island mode when there is an outage of the larger grid. Microgrids offer a lot of benefits, and there are already quite a few great use cases where facilities like hospitals and campuses have microgrids for resiliency. At Liberty, one example we have built a resiliency renewable microgrid in California to help in an area where there are a lot of public safety power shutoffs because of wildfires. And I've seen the trend of growth to be inevitable for these technologies because of being closer to the end point of use, and therefore to offer greater resiliency to the overall grid.
And Alexina, have you been seeing, what's a use case you like?
For sure, I'm happy to go, although I noticed that Gary came off mute. So Gary, I don't want to jump in front of you if you had something you wanted to mention.
No, I was just going to mention in the same theme of microgrids, storage is one use case that provides some optimism for good resiliency going forward. Storage can address the timing challenge and the variability challenge associated with renewable generation. Also can provide grid services such as supporting stability of the grid. The timing challenge to match renewable generation with load and avoiding any curtailment or underutilization of renewable resources is where bulk storage can also provide benefits. Biggest challenge that we face, though, is the long-term or seasonal storage. Today the bulk of energy storage in the grid is pumped hydro, but all the new storage has been lithium battery based, and so we have seen the prices fall dramatically. So we are seeing investment, but we're also seeing hydrogen emerging for storage, and the infrastructure bill actually has 9.5 billion targeting hydrogen. The round trip efficiency is not as good as battery energy storage, but if we can get the green hydrogen cost down to below $2 a kilogram, there's optimism that it can be part of our energy future, be a use case that we can deploy going forward. The other thing I'd mention on microgrids, we're seeing, grid forming inverters now being used with the energy storage. So we can take a microgrid, use it for 100% renewable generation when operating in island mode, as well as provide resiliency when, separating from the grid to serve critical loads whenever there's a disruption. So when you combine the capabilities of the microgrid controls that are available today with storage, I think that's a very compelling use case.
I love that both you, Andrea, and Gary mentioned microgrids and storage. I certainly am very excited about those as near-term technologies or approaches to assembling technology. AES is obviously, well positioned in the storage area, and we do a lot of thinking about how even just the location of storage, for example, on a transmission level, how can that build resiliency or solve CapEx issues within the system in the near term, help us think about how we can basically dispatch electrons or energy at the right place at the right time, just through basically having a battery, thoughtfully located in that transmission level. On the microgrid, there's a AES project that I often enjoy speaking about, which is on Hawaii, the island of Kauai, where AES worked with KIUC to increase renewable energy supply on the island, despite the fact that they had already sort of reached their upper limit on solar energy on the island. So that challenge of are renewables really something that can get us over that last mile of resiliency. And what we were able to do is we were able to partner with the Navy, and they had a big base location, or they have a big base location, and they have great demand for energy. And so, we were able to put solar plus storage on the Navy facility. And in typical operation, that additional solar is feeding the KIUC grid and serving customers with that renewable energy supply. But in situations of disruption or risk, or the need to serve critical U.S. missions, the Navy is able to actually island off in that microgrid sense, that islanding sense, and maintain full supply of the power for the base. So that's a very specific use case, but just, it doesn't require an exponential technological leap. It's a lot of relationship building and sort of thinking about what are the demands of not only an individual customer, but the community surrounding the customer, and how can we actually, in a way, create pods of beneficial uses where, you have larger customers with the ability to subsidize or, fund these renewable transitions, and yet share the benefits with the larger community. So that's a very exciting near-term use case. And Dylan, I won't take up all of the time here, but I will bookmark for the audience that I really enjoy nerding out some on the idea of how, as we look at rebuilding or rethinking the grid, use cases around using distributed energy resources to basically stack the grid from lowest community levels all the way up to what's currently our transmission layer, so that you're calling on resources upwards and downwards at any layer of the grid in order to bring resiliency and security to the delivery of energy throughout the system. So that's more, long shot technology, but batteries, microgrids, solar are fantastic near-term solutions.
Yeah, I mean, and yeah, I definitely think that the relationship there between DERs and storage, as you and Gary both mentioned, is pretty key. So let's talk about digital transformation, which it's being adopted, or you don't adopt transformation, but utilities are across the nation taking on digital transformation. They're moving more digital. So how does this help address threats, and what new challenges does it invite? Let's start with Gary.
Sure. So we actually did a study with Zpryme, I think 2 or 3 years ago, and we did publish the results looking at the digital transformation of utilities and the 3 levels of moving from basically analog to digital transformation. So there's digitization, that conversion from analog to digital, and then digitalization, which is sharing data across the enterprise. And then, of course, business transformation is actually using that information to change business practices and increase, situational awareness. And Alexina, I think you used the term transparency and basically insight into the grid. The components are also, the Internet of Things applied to utility. This is software to control and optimize, for example, the distribution grid with applications like advanced distribution management systems and distributed energy resource management systems, or to analyze and model with applications like asset performance management, digital twins, applying AI and machine learning to the utility operations. And in combining that software with communications, connectivity, and in the smart devices, which are controllable, can, for example, automated switching for reliability purposes. You can switch cap banks and line voltage regulators for volt-var optimization, and also sensors. Some of the devices can be both controllable devices, or they can be sensors as well. So we see utilities in response to the digital transformation deploying digital substations, distribution automation, technologies like image-based inspection, which can feed into asset performance management and different life cycle management applications, new technologies for vegetation management, incorporating, for example, satellite imagery, and improving the knowledge of the condition of distribution circuits, where trees are perhaps cause 90% of weather-related outages on distribution circuits. And then we've talked about microgrids and local energy optimization. I think these are the technologies which are being deployed to better enable us to manage and optimize grid edge resources in particular, but also to give us more insight into grid optimization and operations. One of the challenges, of course, is, as you increase your digital footprint, you're also increasing your digital or your cybersecurity threat base as well, and that's something that we need to keep a perspective on. But we need to be vigilant on cybersecurity regardless as we go forward. So it's not a new threat, but something we need to keep our eye on.
Thanks. And Andrea, do you have anything to add on to that?
I agree with those 2 strong points that Gary just made. On the one side, that digital transformation is making grid operations much more visible in real time, and therefore it helps us to run the grid in a more efficient way and respond more quickly to problems when they do come up. And at the same time, what Gary mentioned, yes, cybersecurity is one of the top concerns and most important areas of grid modernization, because as we have more connected devices and sensors, that creates many more apertures or ways in, right, for hackers to take control of parts of the system. And therefore, yes, I think those are I totally agree with the points that Gary made.
So, Alexina, when we're talking about the capability of technology in modern times, we have the ability to address pretty much any threat that comes up if you just do enough research and spend enough money. But that's in a perfect world. We don't live in a perfect world. So where are the roadblocks to addressing these challenges if it's not technological capability?
Well, I'm not sure if I totally appreciated your question. So let me give it a shot. And what it sounded like to me was, as we're looking at using technology to solve our challenges, right? Information is a critical input to a successful digital implementation. And it actually, not trying to convert your question to my purpose, but as I was listening to Andrea and Gary, thinking about the power of digital transformation, certainly if I appreciated your question, the good data in is essential, right? And anyone who has implemented a digital system has often learned at the beginning, wow, I thought some data was available and it's not, or I thought some data was available, but it's not really testing very well in the technology. It's not validating effectively, if someone's in a utility system and looking at wires, well, are there visible wires and are there underground wires? And how are we even thinking about the data we're collecting on things that are unknown? Back to the earlier point I made of, the grid system that we have having been implemented before we were cataloging the assets on the system. How do we make up for that at speed? And then, so one of the points that was in a conversation I was having today was that while there are data challenges and you need good data in to get good results out, there's also an urgency around enabling the use of digital in this complex and growing energy space, distributed energy resource space. But that one of the data sources that is not always thought of as a necessary input is that as we transition to digital technologies, we are often losing or leaving behind the human elements that we currently use in our system and rely on in our system. So how do we think about embedding the human knowledge, the human awareness of how to effectively operate a resilient system into the digital tools that we're creating? So just want to highlight that for people to think about as we move more digital. How do we ensure we don't lose those benefits of the people that we currently have as experts in the field?
Thank you for that. And yeah, I'm the guy with the background, the guy who works in media. So feel free to challenge any of my assertions in the way I frame these questions. But yeah, I am also interested in what sorts of best practices to overcome modern challenges there are. So Gary, where are there opportunities to do things more efficiently? Where are there threats that are being backburnered, that kind of thing?
So just trying to follow up on the question regarding, I guess, the roadblocks to capability of technology. Certainly data management is going to be one issue, just following up on what Alexina said regarding the digital transformation. I guess I look at other challenges in terms of digital deployment and investment in the grid. So one is just, cost recovery and issues in improving interagency cooperation across federal, state, independent system operators or regional transmission operators who are responsible for regional planning, developers and the operators. I think people are ready to make investment. The cost of all of this infrastructure is another issue, but I think people are ready to make this investment if there is a positive business case and there's clarity in terms of the path forward, whether it's related to transmission investment and can we get the right of way, whether it's offshore wind and can we get clarity on when leases will open up and when we'll be able to get the transmission in place so that the developers can forward, and we can make the public-private investments needed in the supply chain. So it's those types of issues which I think, as we adapt to the energy transition, as we adapt to the digital technologies, these are some of the issues that we need to address. Other things that I think also are somewhat roadblocks. We have a workforce that's aging and will need to be retrained on all the new technologies. Also, we need to continue to work on customer engagement. We've put in smart meters across a number of utilities across the country, but we're still not fully utilizing the capability of that technology. So I think these are some of the other challenges that we have to face. But siting and permitting access for transmission is one of the big ones that we look at, and we're optimistic that the DOE's new Grid Deployment Authority will make an impact with the national corridor. So that will enable transmission investment, which we think is critical to the growth in renewable generation. So just some of the things that we're looking at and wrestling with as the industry moves forward.
Thank you. And Andrea, what are you thinking about when it comes to those roadblocks?
Yes, thank you. So going back to a point that Alexina made on technology and humans, right? How are we designing? And sometimes I'm concerned that we fall into this idea that the capability of technology is unquestionable. And it is true that we have most of the hardware and a lot of the software solutions and capabilities that we need to modernize the grid. But the world has never seen what we are working to build today. It doesn't exist yet, and it never has. So to get all these different technologies and systems to work together in a safe and reliable way is really a huge job and has a lot of complexity to it. So solving that complexity while the grid, right, is in use and hundreds of millions of people are relying on it to not breaking down while we rebuild it is very challenging technically. Another big challenge is that grid assets are expensive. Gary mentioned these, and they last a long time. So there is a lot of inertia in the system, right? In the sense that hundreds of billions of dollars worth of heavy fixed assets are in place. And it can be a huge business challenge to make a change from what is already in place. What so much money and effort has been invested into, and make a choice to do something different, where we'll then be locked into that choice for the next 20 years or more. So for me, the most important strategy, how do we address all this complexity of building this thing we have never built before? It all comes back to people and ways of working together. We can overcome the technical and business challenges if we work well together. Alexina today also mentioned about this microgrid project that requires partnerships. So new technologies, new functionalities bring also new business models, new commercial models, new partnerships, right? So it's very important we work well together. So what I focus on more than anything else is how to build up and bring out peak performance in innovation teams. So I would argue here that to address this, the most important strategy for any company in the energy sector is to focus on how to do innovation well, empower everyone in the company to participate in innovation, and especially engage our people who are on the front lines in identifying the problems we need to solve and developing new solutions.
So, Alexina, from your perspective, what is the single most important strategy, either of the ones you mentioned or one that we haven't yet, to ensure long-term resiliency challenges are met?
Yeah, so I think this also dovetails well with your prior question. So Dylan, certainly didn't mean to change your question on you, because I think your questions are quite good. I do agree that one of the biggest roadblocks is this working together. And so to me, that is also one of the most important strategies, is to actually be able to change this system, and as Andrea mentioned, like a critical system that we're currently using and we need to be using as we change it, right? The plane flying and redesigning it or building it, analogy that's often used. And so to do that, I think we need to come together and agree on what is the new standard, the new approach, the new way of managing these intermittent, numerous, growing energy assets, in a way where we can do this at speed, because we have very little time to get this right. And of course, where it's complex, as Andrea mentioned, as it's involves numerous parties, it's a challenging thing to build something new. You know, there's chance for making mistakes, and mistakes unfortunately often reinforce resistance to change. And so if we come together, have participation from the broad segments of market participants in energy, then we can agree on approaches to this change and then enact as an ecosystem the foundational change that I think we need to see in order to support our future energy systems and assets and customer demands, all the great things that the other speakers on this panel have been mentioning. So number one strategy is to work together.
Thank you. Gary, same question. What's the most important strategy?
There's a lot of important strategies, but I'm going to pick interregional transmission investment. Increasing the ability to move power east-west and between Texas and the eastern and western interconnections. Studies such as ACOR's Macrogrid initiative, which references some of the work that NREL did. Also, Brattle has done some study work. All these studies have shown that the benefits of transmission investment to enable additional renewable generation, the benefits exceed the cost, typically like $1, you get $2.50 in benefit for every dollar that you invest. You know, this enables the grid to support more renewables, basically by reducing grid congestion. When you change the location of generation, you change the power flows, which can lead to a less optimal transmission grid, also grid access. Then enabling interregional power flow to help address the location issue I just mentioned, but also timing issues. For example, California's solar PV can be used for evening demand in Chicago, or wind in North Dakota can be used for helping to meet the California evening peak demand. You have that flexibility to move power and better match renewable generation to the load. And then the other thing that is a benefit is just the overall resiliency and having more flexibility. So if Texas could have benefited if there was more transmission interconnections, for example, maybe not to the west, but perhaps farther to the east, there could have been available power. Same thing with California when dealing with some of the heat waves that they've seen. Having more transmission capacity may be able to help them, as well as some of the demand response programs that they used to work their way through the heat wave. So it gives an added layer of resiliency, flexibility, and it does enable faster penetration of renewable generation, something that we need to address, and we really need a national transmission plan to do.
That's very interesting. Andrea, what about you?
Yes, so again, I would say that we structurally within companies, I'd say we have to focus on how we do innovation and how we engage all of our people and align incentives to give everyone in the company a stake in creating new solutions and scaling them up. So it's embracing the entrepreneurial spirit of your workforce and figuring out how to do this efficiently. There are strategies for these innovation hubs. That's a great way to go at this. But external to utility companies, the regulators have been working for years on the right rules to guide grid modernization, and I think it's fair to say no one has rules, no one has that rules and regulations piece completely solved yet. So inside companies, I would say how we are structured to incentivize innovation, and externally, the rules and regulations that the entire sector operates under, from the big transmission and bulk power level down to the local level. For example, who gets to own DERs and how the full value stack they are able to produce technically can be monetized in the market.
Thank you, Andrea, for that answer and for everything you've provided on this panel. It was really engaging. Thank you, Alexina. Thank you, Gary. This has been a wonderful discussion on resiliency, and I know we've only just scratched the surface. It's like the defining issue of our time. But yeah, with that, I guess we'll put a close on to day 3. Thank you all for attending the conference today. We will be back tomorrow at 10:05 for the final day. So make sure you're getting your friends registered online at energythoughtsummit.com for free. Have a great rest of your day, and we'll see y'all tomorrow.
Thank you, Dylan, Gary, Andrea. Great talking with you.
Thank
Great,
you.
thank you.